Okay, everyone, let's continue. Now it's the last one, technical principles and application of storage. So first one, why we need to learn about the storage, because in the long period of time, data center storage and data center networks are planned, deployed, and maintained by different teams. As a result, storage energies and network energies have different technical knowledge and O&M habits. So as the data center convergency technologies are used, storage networks are evolving towards all IP networks. For the cloud fabric solution, we use the all IP, all Ethernet networks for the storage network. So which enforce the network engineers to understand the storage technologies and the applications of the storage. So this course we will have the simple introduction about the storage network, what is enterprise storage, and the storage median ports and the networks in the data center network. So after this course, you will be able to understand the deployment of storage network, what is enterprise storage network, and the storage network protocols and the storage medium. So first, the storage basics, the storage technology background. The storage, for example, a disk. Okay, a disk is used to provide storage space for compute operating system. The disk is called a block device or block storage, which will be divided into blocks of a fixed size by the OS. It maps the disk space to the host, but before the host can use the block device, the file system is needed. We have to first thing when we get when we insert the disk to a computer, then the computer will divide the disk to a block device, and then we will separate the disk space to a fixed block, and then we will create the file system, and then after that the OS can use the file system. This is the block storage and file system, and this how the disk are used by our operator system. And this is the traditional computer, or we can say this is the PC storage system. So what's the problems of this kind of computer storage system? We can see from 5 perspectives. The first is the performance, the capacity, reliability, utilization, and data sharing. So the disks become the system performance bottleneck. The limited disk slots cannot provide sufficient capacity, and the data is stored on single disks, so data reliability is low. It's quite low, and the storage space utilization is low because only one PC can use this disk, and the data is stored locally, and the data is not shared to cannot be shared to other host. So this is the problems of traditional computer storage system. So how we gonna solve these problems? The first one, we can use the JBOD, just a bunch of disks. Okay, then we can bond the disks together and use the optical fiber or electrical cable connect to the storage port of a server or a PC, then the capacity will be increased and the reliability can be higher. But the performance and the utilization and data sharing problems is still not solved. So then we can use intelligent disk arrays, and we will have a controller in this kind of solution, and the controller is configured on the external disk array. The controller can provide features like cache and redundant arrays of independent disk read, which is known as read. And it is identified by the host as a high-performance disk with redundancy. The controller can combine several disks together, and it can uh, uh, provide the redundancy of the disk. And once one disk is failed, we can restore the data through other disk. This is the emergency of intelligent disk arrays. But the utilization and data sharing problems still not be solved. So then we have the storage network. We use the storage network to provide the storage service to the servers. And we in this figure we can see we have a dedicated storage device, and inside of this storage device it may have many disks, and we can deploy RAID, and this storage device can provide storage service for all these servers. So the performance, the capacity, the reliability, the utilization, and data sharing problem are solved. This is the storage network, and in nowadays data center, the storage network can be divided into three types: the DAS, the SAN, the NAS. The DAS means directed attached storage, means the storage are directly connected to servers through cables or optical fibers. This is DAS. And for the SAN, storage area network, the storage device connects to application servers over a dedicated network for access between the host and the storage device. We may use the fiber channel network or Ethernet between the storage device and the application server, and the storage device mostly provide the block storage service, and the NAS, network attached storage, it is a file sharing service. The storage provide the file storage service for application server, and we can only use Ethernet as the network. Okay, and that's the storage technology background. And then let's see what is enterprise storage development. Not similar, don't like our personal computer system. The enterprise storage requires high reliability, high performance, and large capacity. And usually, The enterprise storage is a logical storage system consisting of multiple disks, and the storage disk system connects to computer system through a storage network and provide data accessing, data management, data protection, and multi-system data sharing. For example, this is a IT infrastructure of an enterprise. Then we will have a enterprise storage system. Here it is an enterprise storage system, and we have some service like file server, mail server, and database server. The data are stored in the storage system, and the external users and employees, they can use web server, the application server, the file server, or so on. And the data are stored in the enterprise storage system. This is the typical IT infrastructure of an enterprise network, and also as well as the enterprise storage. And let's see the enterprise storage development. The storage developed from the tab to now solid state storage. The all solid the SSD are used in our all SSD are used in our storage system. This is the enterprise storage development, and this is the evolution. One from disk to disk arrays, and the unified storage converge SAN and NAS. The enterprise storage will provide NAS, the block will provide the block storage service and file storage service. At the same time, with one storage system. This is called Evolution 1, Unified Storage Convergent SAN and NAS. And Evolution 3, Emergency of Distributed Storage System. We use dedicated centralized storage in some enterprise network. This device with high performance and reliability and limited capacity of a single device, and in most of situations, those devices are very expensive and they are not compatible between different vendors. This is the centralized storage. They have high performance and reliability, but low capacity and low extension. And we can deploy distributed storage in some other enterprises which use standard devices. In the most situation, we use servers. We use the computer servers with built-in storage slot, and it can be faster procurement and rollout, and the linear expansion of storage performance and capacity. The expense of the storage is much more lower than centralized storage, and the expansion is very convenient and very easy to get. Okay, this is the evolution 3. This is evolution 3. Then let's look at the evolution 4, the development of all-flash technology. In this evolution, we use much more high-end disks like the SCM, NVMe disk. This is the all-flash technology that are in the in the evolution 4. Okay, that's all about the enterprise storage background. And then let's look at the storage technology principles. The first is the basic concept. Before we learn about the storage, we have to know what is storage and what is the role of the storage device in the IT infrastructure of the industrial. So this section will describe the concept of CPU, memory, disk, and bus of a server. So you will know why we need the storage and how the storage is used. Okay, let's see the basic server components. The CPU is the central processing unit. It is an integrated circuit acting as the computing core and control unit of a computer. It is the brain of the server. And the memory. The memory is storage component between the CPU and external storage. In other words, the memory is for the short memory, for the short term. Is for the short term. Okay, this is the function of memory. And for the disk, we have, this is the storage device in the server. We have the serial ATA SATA disk and SAS disk, M.2 SSD, NVMe SSD. This is the common disk. This is for the long-term store memory. The long-term memory. The speed of memory is much more faster than disk, and the disk is so the memory, that's the difference between the memory and disk. The cost of memory is much more higher than disk as well. And for other components, we have RAID card, which is used to provide the redundancy of the disk. And we have the PCI slot in the server. This is the slot. Then we can use this PCIe slot to expansion the server. For example, we can insert the GPU chips, the RAID cards. We can plug the RAID cards to the PCIe slot, and also the NIC cards or the other disks can use the PCIe slot. Okay, this is the basic server components. And about the computer bus. The bus is a public communication channel. It's a bridge between the functional components of a computer. The computers, the memories, the storage, the disks, they are all connected to the bus. And the communication is implemented through the bus. It can be serial or parallel bus. We have serial and parallel buses, and compare with the parallel transmission that suffers crosstalk, difficult cloud synchronization, and costly multi-bit widths. Serial transmission can offer the advantages of fast data transmission frequency and speed. So the serial bus is used. Serial bus like SATA bus, and the serial attached SCSI are used, or PCIe are used, because they all compatible with the serial bus, serial transmission. This is the computer bus, and the PCIe, PCI expression. It is a high performance, high bandwidth, and serial bus communication standard. And we have the PCIe interface, and the PCIe standard. The PCIe bus is like this. We have a root complex, and a switch, and PCIe. These endpoints, they are the main component of in the structure of PCIe. The root complex is the PCIe root bridge. A root complex may contain several PCIe root ports, and each root port can connect to device such as GPU through a PCIe bus, and or else to a switch that extends more PCIe bus for connecting. The device, like the memory, the GPU, they can directly connect to the root complex, or they can connect the root complex through a switch. And the memory, the CPU, they are all called PCIe endpoints. This is the PCIe, and this is the PCIe slot and the transfer rate. The PCIe can provide different size of interface, like the multiple 1, multiple 4, multiply 6, 8, and 16, They have different transfer rate. This is the PCIe slots. And for the storage protocol, we have the most popular one, SCSI, Small Computer System Interface. It was first used as an interface for computer disk. It defines physical interface, transport protocol, and command set, and it's also a bus protocol. The SCSI protocol. It is a huge protocol system involved from SCSI 1. We have SCSI 1, SCSI 2, and SCSI 3. It defines a model and a necessary command set for different devices to exchange the information use the framework. This is the SCSI. And then the SCSI 3 standard architecture. This is the SCSI 3 standard architecture. It allows the computers to connect directly to storage device, such as USB, SAS, and SATA device. They all use the SCSI 3 standard, and are able to communicate with external storage device over network, such as IP, infinity band, or fiber channel network. This is the we can say that SCSI is a very big protocol stack. It contains the command sets, the transport protocol, and the interconnections. This is a standard SCSI 3 standard architecture. And for the transport protocol, we have FC. The fiber channel protocol was deployed in 1988. It is used to connect storage medium and resolve the SCSI's issue of short transmission distance. Okay, this is the FC. It is the transport protocol of SCSI. So sometimes we call it FC SCSI. Sometimes we call it FC SCSI. And then the iSCSI, the Internet SCSI protocol. It encapsulates SCSI commands and block data for transmission over a TCP/IP network, over a Ethernet network to reduce the fiber channel network cost. Because the fiber channel network, it requires dedicated fiber channel switches, which cost a lot. So as the this is the iSCSI protocol, and as the transport layer protocols of SCSI, iSCSI uses metro IP network technology to implement and extend the storage network. This is the iSCSI. It is the transport protocol of SCSI. It supports the SCSI protocol runs on the metro IP network, which can reduce the cost, the networking cost. And then for the SAS, serial attached SCSI, it is a serial standard of SCSI bus protocol. It is a bus protocol, and it is a mainstream protocol for local storage transmission. For the FC and the SCSI, they are used for the storage network. Which means the storage are accessed through the network, no matter it is a fiber channel network or it is a IP network. But the SAS protocol, it is for local storage transmission, which means the storage devices are directly connected to the CPU, connect to the bus. Okay, and it used the serial technology to provide high transfer rate and better scalability. Okay, this is a SAS, and the other one is a SATA, a serial advanced technology attachment, SATA. It is a serial standard of the 88 bus protocol, and actually the SATA is no longer used in nowadays equipment, and the SAS ports can run SATA instructions, which means the SAS can support the SATA interface, but the SATA cannot is not compatible with SAS. This is the SATA. This is SATA and SAS. And then let's have a simple summary of the SCSI network protocol stack. The upper layer protocol SCSI is unaware of the underlying network. Therefore, various network technology has been developed based on SCSI, such as FC over Ethernet, FCIP, and iSCSI. Here is the brief network stack comparison. Okay, upon this transport protocol, we have the SCSI command set, and then we can use the iSCSI as the transport protocol. We can use FC protocol, and we can even use the FC over Ethernet, FC over IP, or pure FC network. Okay, this is the SCSI network protocol stack. Okay, and then the NVMe, non-volatile memory express, NVMe. It is a scalable chip interface designed for PCIe-based SSID. It is a chip interface. chip interface designed for PCIe based SSID, which means the NVIe interface. NVIe interface is support the PCIe bus, bus standard, and the NVMe allows native PCIe channel to connect directly with CPU, eliminating the latency caused by the communication between the CPU and the external SATA or SAS controller, which means the NVMe provides the lower latency compared to SATA or SAS. This is the advantage of PCIe-based SSID, PCIe-based SSID. Okay, this is the PCIe SSID. Okay, and then this is the NVMe protocol stack. Unlike the SCSI, NVMe reduced the I/O scheduling of SCSI commands to shorten the I/O path, and the NVMe commands interacts are more efficient than the SCSI commands. And this is the NVMe working principles. It used the direct memory access to transfer NVMe commands, and it can provide higher performance compared to the SCSI. That's all we need to know, the NVMe protocol. We can see that it is a advanced technology than SCSI. Okay, and then since the NVMe is a technology that used for the locally connected between the locally connected devices, so the distance is very short. So we have the NVMe over fabrics, which can address the PCIe scalability problems. We have two methods of the NVMe protocol, NVMe over fabrics. The first one is NVMe over fabrics use RDMA, and the second one is NVMe over fabrics using fabric channel, FC-NVMe. And then this is the RDMA protocol stack. The remote direct memory access transfer memory data from one computer to another by using related hardware and network technologies. And the Rocky version 2 is most widely used. This is the RDMA for this one. NVMe over fabrics using RDMA. We have the IB. We can use the IB as the transport protocol, and the the Rocky V1 use the IB as the transport protocol, but it can use the Ethernet link layer as the interconnection medium. And for the Rocky version 2, it uses the UDP and the IP, which allows the RDMA across different network segments. And also we have the IRAP protocol, which can use the IRAP protocol and the IB protocol can be implemented in the Metro IPnet TCP IP network. Okay, this is the RDMA protocol stack, and the NVMe over Rocky. It is a type of the NVMe over fabrics protocol based on RDMA. It has been significantly optimized in terms of performance, cost, network management, and technology technology, and it is gradually become an optimal application of NVMe over fabrics. This is the Rocky, and especially the Rocky version 2. The Rocky version 2, it can use the traditional Ethernet as the interconnection medium, especially the Rocky version 2. Okay, then let's have a summary of the comparison between NVMe and the SCSI protocol. Okay, they are both bus standard, and the NVMe extend the PCIe actually extend the PCIe for the local attached storage. The SCSI has SAS, and the NVMe has the NVMe, and for the remote interconnection, the SCSI can use FC protocol as the transport layer protocol, and we have FCI SCSI, and it can use TCP/IP as the transport layer, and we have iSCSI. And for the NVMe, we have FC NVMe and FC NVMe over fabric. And the third one of the storage technology principles, we gonna look at the storage medium and ports. It is about the physical features of this storage device. Okay, this is the evolution process of the storage medium and the storage protocols. And the overview of storage medium, we can separate the storage medium into three types: HDD, SSD, and the SCM. And the HDD and SSD is mostly widely used. Okay, and the disk port, the interface, actually this is the interface on the disk. Okay, and different disk ports support different instructors. For example, the IDE ports and the SATA ports, they only used for ATA instruction system, and the Paroline SCSI port, the SAS port, the fiber channel disk port, they only used for SCSI instructions system, and the PCIe ports are used for NVMe instruction systems. And this is the IDE and SATA. Actually, these two kind of interface are no longer used in nowadays device. And the disk ports of SCSI, SAS, and FC, which support SCSI instructors. These are the features, and those are the features of this storage disk ports And then the PCIe SSID, this is used for NVMe SSD disk. It is upper layer protocol. It supports the transfer data at a physical layer, which can provide the lowest latency and highest performance. PCIe SSD. This is the mapping between the disk medium and the port. Then let's have a summary of the of all these knowledges by look at the storage technologies application in DC. This is the data center network. We are going to have a service network, the storage network, and the storage network use centralized storage or use distributed storage. Okay, and these are servers. They are computer node. They provide specific service through the service network. For example, it provides the HTTP service. It provides the email service. Okay, And then let's see the process of one storage activity. In a data center, applications are installed and run on server and provide service through a service network. That's what I just talked about. For example, the HTTP service, right? The email service. And a server may has disks for installing a server's OS. The server perform I/O operation on disk. Use SCSI or NVMe because it is a locally attached disk. It has a locally attached disk for install server OS, and the application are installed. The application provide, for example, the HTTP server, the email server. These are applications installed in the server, and the application data. The amount of the application's data is huge, so it is stored on external storage device. For example, we have a storage system. Okay, when applications wants to perform a I/O operation on data, it send a request to external device through a storage network by using NICs. For example, we have a client here. It wants to read or write the application data. Then the data will be sent, the requirement will be sent through the service network to the server, and then the server will send the I/O requirement to the storage system through the storage network. Okay, and according to different storage network, different storage protocol will be used. For example, if I use IP storage network, maybe I will use the iSCSI protocol or Loki version 2 protocol. If I use the FC storage protocol, then FC-SCSI or FC-NVMe protocol will be used. So the I/O operation, for example, the instructions will be transferred through the storage network until it arrives at the storage system. Take the centralized storage as an example. It consists of a controller's interface module and disk enclosures. The controller is the core component, and it process storage services, receive configuration and management commands, save configuration data, and access disks. So the I/O requirements will be processed by the controller, and then the controller will deliver the operation. It will perform the operation to different disks on the inside of the disk enclosure. Okay, it will perform the I/O operation of physical on the specific physical disks. Okay, that's the whole process of the I/O, of the storage system in the data center network. Okay, and that's all about the technical principles of the storage in the DC network. Okay.